Right, back again with exercise 11C, question 2. A large urn filled with water turned on and the water was heated until its temperature reached 95 degrees Celsius. This occurred at exactly 2 p.m., at which time the urn was turned off and water began to cool. The temperature of the room where the urn was located remained constant at 15 degrees. Commencing at 2 p.m. and finishing at midnight, Jenny measured the temperature of water every hour on the hour for the next 10 hours and she recorded the results. Wouldn't you hate to be a scientist? Maths is a lot better. Imagine having to do that. Anyway, at 4 p.m, Jenny recorded the temperature of the water as 55 degrees Celsius. She found the temperature of the water could be described by the equation. The maths, that's what we were after. T equals AE to the negative KT. Let's write that. Oh, well, too bad. You're getting red pen. Plus 15. And this is for the domain 0, T, and 10. T between 0 and 10 hours, where T is the number of hours after 2 p.m. Find the values of A and K. All right, well, let's do this first. We know some information, don't we? We know that at 2 p.m, and this time is measured as the time after 2 p.m. Well, at 2 p.m, the temperature was 95 degrees. So when T equals 0, oh, my computer didn't cope. When T equals 0, capital T equals 95. Let's go ahead and see what that tells us. 95 equals A, e to the KT. Well, that's all going to be 1, isn't it? Because temperature of 0, something to the power of 0. 1, okay, so A plus, it should be 15 there. I'm sure I said 15, but it didn't seem to want to write correctly. Subtract 15 from each side, and I've got 80 is equal to A. Great, so we've got that value there. How do we go about finding T? Well, they tell us another piece of information. At 4 p.m, Jenny recorded the temperature of the water as 55. Well, let's write what we've got first. So now I've got T equals 80 e to the negative KT plus 15. And I'm going to say, let capital T, the temperature, equal 55. And little t, the time, and this was at 4 p.m, so that's 2 hours after 2 p.m. T is going to equal 2. I'm going to be able to solve for K now, aren't I? So I've got 55 equals 80 e to the negative 2k plus 15. A little bit of rearranging here. 40 equals 80 e to the negative 2k. 1/2 equals e to the negative 2k. Log of 1/2 equals negative 2k. Divide by negative 2. Negative 2 log of 1/2. Why did I say divide and then multiply? Is equal to k. It's because I was thinking about what can we do to make that look a little bit nicer. That's fine. If you use that, you're not going to have any problems. You'll be fine. But log of 1/2, that's... Oh, isn't it the same as the log of 2 to the negative 1 over negative 2? And then I could put the negative out the front. Negative log 2 over negative 2. And it's just going to be a little bit nicer if I use the log of 2 divided by 2 as opposed to the log of 1/2 divided by negative 2. I'm going to go with that. It doesn't really matter if you didn't. But now we've found our values. So I've got just rewrite my equation again. T equals 80 e, and then it's to the power of negative k. So negative T ln 2 divided by 2. I'll just put the T in front there because it looks nicer. You can have it after that. It doesn't really matter to me. In fact, some of you may prefer it after, so why don't I write it like that as well? The reason I put it in front of the log is so that it looks a bit clearer, but we can also do it like that and just leave that entire value in front. Lots of ways you can write it. Either way, you'll be fine. We've got our plus 15. Also, try not to make it look too large, like it's part of the equation, and subtracting it, that needs to look like an exponent. Maybe I haven't made that clear enough. Let's do that again. There you go. Now it looks more like an exponent. It's important we try to be clear for those people who are going to read our maths. Isn't that right, Mark? All right. Next, find the temperature of the water at midnight. Midnight is 10 hours after 2 p.m. So I'm just going to say let little t equal 10. So I'm going to have capital T. The temperature is going to be 80 E, and we have ln2 negative ln 2 over 2 times 10 for the number of hours plus 15. Let's just go ahead and work out what that is. That's going to be e to the negative 5 ln 2. So, calculator's out. 80 times e to the power of bracket negative 5 log 2. Close my bracket on that. Add 15. And that's giving me an answer of 17.5 degrees. 17.5. That seems pretty reasonable to me. It seems like a reasonable assumption that it would be pretty close to the room temperature after 10 hours. So I think that's all right. Part C. At what time did Jenny first record a temperature less than 24 degrees? Well, let's go to part C, and I'm going to let capital T equal 24. Therefore, 24 is equal to 80 e to the negative ln 2 over 2 times t plus 15. Rearranging time, let's subtract that 15 first. That's going to leave me with 9 equals 80 e to the negative ln 2 over 2 t. We're getting there. Divide by 80. 9 over 80 equals e to the negative ln 2 over 2 t. Natural log of each side. So I've got the natural log of 9 over 80. That's going to equal negative ln 2 over 2t. Multiplied by the reciprocal, I'm going to have negative 2 ln 9 over 80. So that's multiplying by negative 2. And then dividing by ln 2 equals t. Beautiful exact answer, but let's keep everyone happy and figure out what that is as an ugly decimal. All right. Negative 2 times natural log bracket 9 over 80. Isn't this fun watching me push buttons on the calculator? That equals that. I'm going to divide that by the natural log of 2. That's telling me t is approximately equal to, there's my stylus, 6.3 hours. Does it say when, or does it say after how many hours? At what time? So 2 p.m. plus 6.3 hours, that's going to be 8, and 0.3 of an hour is 18 minutes, isn't it? So at approximately 8:18 p.m. the temperature dropped to 24 degrees. I think that was what we were working with, wasn't it? Yeah. Sketch a graph of t against little t. Well, I'm hoping you could use your calculator to do that. But if you were stuck and you didn't have a calculator, what's happening? Well, it's approaching. It's an exponential decay graph. We all know the basic shape of one of those is like that. But it's been shifted 15 up. It starts here at time equals 0. We can't do it before that. That's at 95. And it's going to go down and follow that shape. And we're going to have an asymptote there at 15. I think that would be a reasonable attempt for that one. We'd probably want to label our axes though, wouldn't we? T and capital T of little t. That would be, we could even give it time in hours after 2 p.m. And capital T of t, of course, that is degrees Celsius. If you wanted to put in the little marker there showing that it was 55 after 2 hours, you could. And that would be more than enough for you to be getting the marks there. Of course, that would probably be on a calculator question. You could answer it with your calculator, but otherwise you'll be fine either way. Good luck. Thank you for finally putting some questions in the collaboration space. It's really important you take advantage of that. You're going to be able to get lots of help. Keep up the good work, Year 12s. We will catch you next time. Bye for now.